Let's recall stereo warehouse example. In this example, the store wants to determine the number of X receivers and Y speakers to stock. So we identified our decision variables accordingly. X denotes the number of receivers to stock and Y denotes the number of speakers to stock. The unit wholesale cost, the unit display space requirement, and the unit price for these receivers and speakers are already provided. We have budget constraint, as you see here, and also we have sales limit for receivers. First, we formulated the problem as a linear programming formulation, as you see here. As you can remember, we have identified the profit contributions for the receivers and speakers. Then, based on the identified three prioritized goals, we have started to formulate our goal programming model. These are the prioritized goals that are given to us by the decision maker. Here, as we stated before, the first and third goals are more straightforward compared to the second priority goal. For each expression in these goals, we have defined two deviation variables. Okay? For instance, D1 plus and D1 minus are defined for profit goal. D2 minus and D2 plus are defined as deviation variables for floor space goal. D3 minus and D3 plus are defined for budget goal. D4 minus and D4 plus are defined for sales limit of receivers. PK denotes the priority level with rank K. Okay, the first priority goal states that exceeding sales limit of 60 receivers should be avoided. Therefore, the corresponding deviation variables D4 minus and D4 plus should be used in order to transform this goal to a constraint in the goal programming model. Okay, how do we do that? We add plus D4 minus and minus D4 plus and make this equality in the resulting goal programming formulation. Let's continue with the other straightforward goal, which is the third priority goal. It states that the deviation from floor space usage should be avoided. This corresponds to this goal, 2x plus 4y should be 400. So we should add the corresponding deviation variables. What are those? D2 minus and D2 plus to this goal in order to obtain a constraint for the goal programming formulation. Okay, so as you see, 2x plus 4y plus D2 minus minus D2 plus should be 400 in the goal programming formulation. Okay, the second priority goal states that meeting budget is twice as important as maximizing profit. So we should express budget and profit as mathematical expressions, and we should use the corresponding deviation variables in order to transform these expressions to constraints to be included in the goal programming formulation. For budget goal, what are the deviation variables? D3 minus and D3 plus. This is the corresponding expression. So we should add these deviation variables and we should transform this goal to a constraint to be included in the goal programming formulation. As we have an upper limit for this goal, what should we do? We should penalize D3 plus, right? So D3 plus should be included in the objective function. Right now, we are not dealing with its coefficient. Then we should also consider profit in this goal. As it is stated, profit should be maximized. We have identified a hypothetical limit as 99,999 for this goal. And we said that the profit should be greater than or equal to this value. So this corresponds to a lower one-sided goal. It behaves as a lower one-sided goal where we want to penalize the shortfall from this goal. The excess deviation variable shouldn't be penalized in this case because we are trying to maximize the profit. That means that D1 minus should be penalized. Okay, and there is one more information in the description of the goal. It states that meeting budget is twice as important as maximizing profit. So the budget penalty should be twice as large as the profit deviation penalty. That's why here we multiply D3 plus by 2 and we multiply D1 minus by 1 and then multiply all these by the rate of the corresponding goal. Okay, this is the non-preemptive version of this problem. Okay, as you see, for each goal, we have a penalty coefficient and we multiply the corresponding deviation variable or the expression corresponding to this goal with the penalty coefficient. Next, we will solve this problem using preemptive approach on Excel. Okay, let's open our Excel sheets. Okay, we should start with first priority goal. These are our decision variables. I have already prepared them. X and Y corresponds to the number of units to be stocked for receivers and speakers respectively. And these are deviation variables for profit, space, budget, and sales limit expressions. Our first priority goal is avoiding exceeding sales limit, right? So we should minimize which variable? Let me show our model. We should minimize D4 plus, right? Since it is an upper one-sided goal. Okay, so this should correspond to D4 plus. And then we should write our profit goal. Number of X receivers times its price minus wholesale cost plus number of Y speakers times its price minus wholesale cost, right? And what should we add? We should include profit deviation variables plus D1 minus D1 plus. Okay, this is the right-hand side. We have identified our hypothetical limit for profit function as 99,999. Continue with space goal. So number of receivers times receiver space requirement plus number of speakers times speaker space requirement. And also we should include deviation variables corresponding to space, right? Okay, this is the okay, this is our left-hand side for the space goal, and the right-hand side comes from data. We have a space limit of 400 square feet. We can continue with budget goal. Okay, for budget goal, we should multiply the number of X receivers by its wholesale cost plus number of Y speakers pairs actually by its wholesale cost. And also we should include deviation variables for the budget. Okay. And what is our budget limit? It comes from data. It is 8,000. We have sales limit goal for receivers. Okay, so X plus D4 minus D4 plus should be 60, which comes from data. Okay, so this is the goal programming model that corresponds to the first priority goal. So we can enter the solver parameters. This is our objective. This should be minimized, and these are our decision variables, right? And all constraints are equality, so we can add them as a single constraint to our model, okay? Okay, and then we will solve it by using simple LP. We know that all variables are non-negative, so we should check this checkbox, and then we should press solve. This is the result. That means that D4 plus is 0. That means the first priority goal is satisfied with a deviation of 0. Okay? For the second priority goal, D4 plus should be equal to optimal objective function value, or D4 plus value of the first model. Okay, similarly, we should construct our objective function and the constraints. Okay, for this second priority goal, what is our objective? D4 minus plus 2 times D2 plus should be minimized. D1 minus plus 2 times D3 plus should be minimized. We can copy these cells and paste them as formula here. We should also include one more constraint in order to set the deviation variable's optimal value for the first goal. Okay, it was D4 plus, as you see here, and we should feed this value to the second priority goal programming model as a constraint. Okay, let's solve it. Okay, so get this value. After obtaining this value, what should we do? We should use the optimal values for D3 plus and D1 minus in the third priority goal programming formulation. Okay. By using the same model in the goal programming formulation of the third model, we should include these constraints that set the optimal values for these variables. Okay, let me do this as well. In the third model, our objective is D2 minus plus D2 plus. So this should be D2 minus plus D2 plus. And again, we should copy the constraints, and we should add the constraints that set the optimal values for the deviation variables that are obtained in the first priority and second priority goal programming formulations. For the first one, we should set D4 plus, right? For the second one, which deviation variables we have obtained, D1 minus, D3 plus, D1 minus, D1 minus, and the other one is D3 plus, okay? D4 plus, D1 minus, D3 plus, okay? And again, these should be equality. Let me copy this. And the 4 plus value should come from the solution of the second model. Similarly, the 1 minus should come from the optimal solution of the second model, and the 3 plus should come from the optimal solution of the second model. Then we can solve this model. Okay, this is the optimal solution for the third priority goal programming model. That means we have a space utilization which is 120 less than the current available space. We can also solve this problem by using non-preemptive goal programming formulation. However, we require the values for P1, P2, and P3.